So the introduction unit on polar graphs requires you to learn some terminology. You have a polar grid, which looks like this. Now notice that you have angles, could be in terms of degrees or radians, starting with the positive x-axis and rotating counterclockwise. It's like standard position in graphing points in trigonometry, and um, and you could also have a positive direction, which would be this direction, or you could have a negative direction, which is this way. You also have a point in the middle, which is called the pole instead of the origin, and you're going to have a directed angle, and you're going to have a directed distance. So the directed angle would be your 60 degrees here, and your directed distance would be 3. Notice that you're going to have the point, which is now r theta. R theta, direct distance, directed angle. So how do you graph certain points on the polar graph? And it just requires some practice, and then it really doesn't become too difficult. What you're basically doing is looking at the angle, 60 degrees, and counting the circles away from the pole until you get to 3, and that's how you would graph that particular point. Let's try this one. Negative 4/3 pi. So I like to look at the angle first. Negative means you're going this direction. This would be 3 pi over 3, and you have to go one more pi over 3 to get here. So that's going to be your angle going this way, and then you're going to go 1, 2, 3, 4 up. So that point is going to be this one right here. On this one, this is a negative 150. Now notice that your distance can be negative, and that can throw students for a loop a little bit here. Negative 150, let's see, that's going to be 150 and 30 would get you to 180, so it's going to be right here. That's the angle you're looking at. And then it says a negative 2.5. Now, if it were positive, you'd go 1, 2.5, but it's negative, so you're actually going the opposite direction. You're going away from where you normally would go, 1, 2.5. That's going to be this point right here. Now, there are several ways of labeling points, the same exact point on a graph. Let's look at number 2 and come up with 3 other ways of labeling the same point. And the easy way to do this is to look at that 4 and say, oh, I've got to do another positive 4 and 2 negative 4s. All 4 points you can graph by positive, negative, 2 positive and 2 negative. So, for example, if I go this direction, the positive direction, and go positive 4, I know that's just going to give me the angle of 2 pi and the directed distance of 4. So it's 4, 2 pi over 3. Now, going the negative direction would be going, looking at this angle right here and then coming back to it, 4 units. So the question really is what is this angle? So you could have, let's see, 5 pi over 6, 6 pi over 6, so the difference is over 3. So the difference is going to be pi over 3, which is negative pi over 3. And if you go this direction, it's 5 pi over 3. And those, again, you're going the positive direction, the negative direction, and then the negative 4, which brings you back to that point. So each of those points can have 4 points if you're going between negative 2 pi and positive 2 pi. Next, you can get different equations of polar coordinates. And so the 2 basic equations are going to be where you have r, which is the directed distance, is 4 units, and an angle, which is a certain radian or degree. So for example, if I want to plot r equals 4, that means I'm going to go 1, 2, 3, 4 units away, and every angle along here is going to satisfy that length of 4 units. And so this is going to be a perfect circle where the length is 4. Now, if you have an angle that's 3 pi over 4, I'm going to go 3 pi over 4. Let's see, it's here to here, and that's my angle, and that means every distance is covered as long as you have that particular angle of being 3 pi over 4. You can have positives, you can have negatives, and so that's going to continue in both directions. Very quickly, negative 300, again, just a little reminder, negative 300, you'd have 60 more to go to 360, so that's going to be right here, and all the distances are going to be covered, which is going to look like this. So plotting points in the positive, negative direction in terms, and also positive, negative distances, getting 4 points per particular point, and a couple different equations, one where it's a circle, that'd be the distance is uniform, and a line, which is where the angle is the same thing.